Okay, so last time we learned how to use trig functions to find side lengths, and we learned that the sine of an angle is equal to the opposite side divided by the hypotenuse, and we learned that the cosine of an angle is equal to the adjacent side divided by the hypotenuse, and the tangent of the angle is equal to the opposite side divided by the adjacent side. So let's just do a quick review of some problems on how we could use that. So let's look at our first one here. I have our 61-degree angle. We're going to start by identifying our angle, and we're going to identify the sides and the names that go with them. So I have a 61 degrees. Over here, opposite of it is 12, so that's our opposite. Across from the right angle is the hypotenuse. And next to our angle here, x, is our adjacent side. So we always want to start by labeling our sides. And we notice we have information given to us about the opposite side and the adjacent side. So if we are looking at opposite and adjacent, let's look up here. That means opposite and adjacent, we are going to use tangent. So we are going to say the tangent of our angle, which is 61 degrees, is equal to the opposite side divided by the adjacent side. So we're going to set this up as a proportion, and we're going to cross multiply. If I cross multiply, 12 times 1 equals 12. And x times 61 is x times the tangent of 61, excuse me. I need to get x by itself, so I'm just going to divide both sides by the tangent of 61. So you're going to want to make sure you get into your Desmos scientific calculator and put 12 divided by the tangent of 61, and you should get 6.7. We're going to go ahead and round to the nearest tenth. On number 2, again, same thing. Let's identify. Here's our 21-degree angle. And opposite of it, we don't have any information about. The hypotenuse we know is 18. That's across from the right angle. And x is our adjacent side. So if I have information about adjacent and hypotenuse, that tells me I am going to use cosine. So I'm going to say the cosine of angle, which is 21 degrees, is equal to my adjacent over hypotenuse. And if I set it up as a proportion, 1 times x is x, and 18 times the cosine of 21. If you go ahead and put that into your Desmos calculator, you should get that x equals 16.8. Okay, one more here, or actually 2 more. I have my 15-degree angle. Opposite of it is x. Across from the right angle is my hypotenuse, and the other side is my adjacent side. I am given information about opposite and hypotenuse, which means if I'm going to have opposite and hypotenuse, that means I would be using sine. So we're going to say the sine of my angle, which is 15 degrees, equals the opposite, which is x, over the hypotenuse, which is 16. So x is going to equal 16 times the sine of 15. If we put that into our calculator, we get approximately 4.1. Last one here. I look at it, I say, uh-oh, I don't have an angle that I know. Okay, all I know is 2 side lengths. But if I know I have 2 side lengths that I know, and it's a right triangle, I don't know anything about my angles right now, I know I can use the Pythagorean theorem to find a missing side length. So we don't have to use trig. If we know 2 side lengths, we can use the Pythagorean theorem. Remember, A and B are our legs. So this is a leg, and this is a leg, and then C is always our hypotenuse. So we would have 3 squared plus x squared equals 4 squared. And just finishing it out, we'd have 9 plus x squared equals 16. If we subtract 9 from both sides, I'd get x squared equals 7. Take the square root and I would have x equals the square root of 7. I can't simplify that anymore. And if we want to know approximately, what that value is, we can put the square root of 7 into our calculator, and it's about 2.6. Okay, so now we're going to move on to actually finding angle measures using trig. Okay, so how can we use trig to find angle measures? Well, if we are given two side lengths of a right triangle, so if you look down here on the bottom, these number 5 and number 6, these examples, they give us two side lengths. Well, we just did a Pythagorean theorem where we could find a third side length, but I want to know how we can use that information to find the angle measure that's missing. So if we want to use trig to find the angle measure, we are going to use the inverse of the trig function. And remember, inverses just undo something. So thinking to what that actually means, when we want to undo, say we have 3x equals 12. If we want to undo 3 times x, we divide. Multiplication and division are inverses of each other. If we have x plus 5 equals 10, if we wanted to get x by itself, we'd have plus 5. We'd want to subtract 5 from both sides. Plus and minus, addition and subtraction, are inverses of each other. Trig functions also have inverses that undo each other. And if you look in your Desmos calculator, okay, so you should have that open, you'll notice if you hit the functions button here, it brings up another screen, and we've been using our sine, cosine, and tangent. We've been using that to find the side lengths. When we want to find our angle measures, we are going to use the ones that have, looks like sine raised to the -1 power. That is actually saying inverse sine. So that's the inverse of our sine, and that's how we are going to undo our sine function. So let's take a look at how that's actually going to work. Okay, so I have a right triangle, and I'm going to, instead of having a question mark here, I'm going to go ahead and call that x. So we have a variable that goes with it. Okay, and if I have my angle, we're going to do the same basic idea that we did last time. I'm going to label my sides. I have over here, opposite of x is 4, across from the right angle is 6, that's our hypotenuse, and our adjacent side that has no information. If I have information about opposite and hypotenuse, I know I'm going to use sine. So let's set that equation up just like we did last time. So we're going to say the sine of the angle, in this case the angle is x. We don't know what the angle is, equals opposite over, I'm going to move that over just a little bit. You'll see why here in just a second. Equals opposite, which is 4, over hypotenuse, which is 6. Okay, we need to get that x all by itself, and in this case we can't just divide by sine, which is what you might think you want to do, because that sine is attached to the x, it's the sine of the angle. So what we need to do is we need to take the inverse of both sides, just like we would divide both sides by 5 or something like that as an inverse. In this case, we are going to take the inverse sine of both sides. So we're going to go like this. We're going to take the inverse of it. Remember that inverse looked like that. And we're going to do that on both sides. Oops, sorry. Okay. What this inverse does is it undoes sines. So what we're going to have is our sines and our inverse are going to undo each other, and all we're going to have left over here is x. And on this side, we're going to have the inverse sine of 4 over 6. We can put this into our calculator, and it will tell us what the measure of the angle is that has a sine ratio of 4 over 6. So if you open up your Desmos calculator, okay, and make sure you're using the inverse sine button, you're going to make it look exactly like it does here. So you're going to hit that inverse sine, and it'll give you a set of parentheses, and you just put 4 over 6 in there, and it will tell you that the measure of that angle that we had missing there is, let's see here, about 41.8 degrees. Okay, so let's kind of take a look at another one here to see how that's going to work. We'll practice it again. So again, I'm just going to call my angle x instead of question mark because it makes more sense to have a variable there. So we're going to call it x. Over here is opposite of our angle. There's no information that we know. We know that this is our hypotenuse and that this is our adjacent side. Okay, so we know we have information about adjacent and hypotenuse, which means we are going to use our cosine. So we're going to say the cosine of x equals our adjacent side, which is 36, over our hypotenuse, which is 51. Again, we don't want the cosine of x, we want x. So we're going to use that inverse. We're going to take the inverse of both sides. So I'm going to take the inverse by saying inverse cosine of both sides. And again, what that inverse does is it gets rid of the cosine here, and we're left with x on this side. And on the other side, we have the inverse cosine of our sides, 36 over 51. And again, this is calculator work for you, so that's kind of nice. So if we put the, and make sure again that you are using the inverse cosine, not regular cosine, because we are finding an angle measure, not a side length anymore. And if you put that into your calculator, you should get that it is approximately 45.1 degrees. Okay, so let's just do a couple more examples here together just to make sure we kind of get the idea, and I'll tell you a little bit of a shortcut that you can use also. Okay, so here's another way to look at it. Okay, so we don't have to actually show our work of saying I'm taking the inverse sine of both sides and things like that. We can actually skip right to this step here. So if I have information about a sine and I'm trying to find an angle, if x is the angle I'm trying to find, I can go straight to using the inverse function. If there's information about sine, I can go directly to my inverse function with cosine, or I can go directly to my inverse function with tangent. Okay, so let's look at how that's going to work out. So we have, again, I'm going to call this a x instead of question mark. Okay, opposite is 45. Our hypotenuse is 49, and our adjacent side we don't know anything about. And if we're using opposite and hypotenuse, that means we are going to use sine. So that means our angle, we can go right to our angle. We're going to have inverse sine of our opposite over hypotenuse, which is 45 over 49. So we can kind of make it go a little bit quicker if we know this relationship and how to use our calculator. So we can put into our calculator the inverse sine. Again, make sure you're using the inverse. And 45 divided by 49, and we should get approximately 66.7 degrees. And we want to label it with degrees because it is an angle measure that we're finding. Okay, let's give ourselves a variable here. Here's x. We're finding the angle measure. So let's see if we're going to use inverse sine, inverse cosine, or inverse tangent. Well, opposite over here, we don't know anything about that. Here's our hypotenuse, and here is our adjacent side. If we have adjacent and hypotenuse, that means we're going to use cosine. So our angle is going to be the inverse cosine of our ratio, which is adjacent over hypotenuse, which is going to be 28 over 39. If you go ahead and put that in the calculator, you should get that x equals approximately 44.1. Would you go ahead and pause the video and try these last two on your own and see what you come up with, and I'll go ahead and work them out, but I want you to pause it and try it on your own first and then check with what you got. Okay, let's see if we agree. Here's my x. All right, let's see what trig ratio we're going to use. Over here is our opposite side. Here's our hypotenuse and our adjacent. Well, we have information about adjacent and opposite, which means we are going to use tangent. So we know our angle is going to equal the inverse tangent of our side ratio, which is opposite over adjacent. So let's go ahead, put that in your calculator, and you should get approximately 68.2 degrees. All right, and kind of moving over here one more time. Let's give ourselves our variable. What function are we going to use? We've got, here's our opposite side, here's the hypotenuse, and our adjacent. Since we know opposite and hypotenuse, that means we're going to use inverse sine. So our angle x is going to equal the inverse sine of our opposite over hypotenuse. And go right to our calculator, and we can put that in there, and we should get approximately 46.1 degrees. Okay. When you finish up here, there's a class kick that you can work on, and let us know if you have any questions.